Hey students, I want to take a minute and go over the rubric that we're going to use to grade the lab reports for the Isopod Behavior Lab. Um, if you look up here, what we need to do is take a look at what it means to be advanced. There are 13 indicators that I'm going to use to grade your performance on the lab report. Each of the indicators has three possibilities or three outcomes. Uh, and again, what I want to do is to try and focus on you obtaining an advance. So I'll go through and explain what each of these means at the advanced level, and you can kind of figure out what the proficient and needs improvement is going to be about. The first one is a question. This is where we always start out with our scientific investigations. We start out with the question. For the isopods, it would be something like if I was investigating whether or not the isopods preferred a pH, it would just simply state that in the question. Do isopods exhibit a preference for a lower pH or a higher pH or whatever your independent variable ends up being? It needs to be stated in such a way that it ties directly to your hypothesis. Is something that is testable. If you ask something that we're unable to test, like do the isopods feel better? Are they sad when they're in an acidic environment? Those are things that you're not going to be able to test, and so therefore they're not very good guiding questions. You need to identify your variables. You need to understand that the independent variable is the variable that you're manipulating, you're changing. Independent variable for, again, a pH test would be a lower pH and a higher pH. So a varied pH level. And then, of course, the dependent variable would be the number of isopods found in that particular environment. So you want to clearly state and identify those two after you've posed your question, and then develop your hypothesis from that. Your hypothesis, what I'd like for you to do is to review the hypothesis writing document that I have on the Canvas site. Hypothesis is testable and clearly stated in an if and then statement. The if and then statement is broken up into two parts, of course. The if is our independent variable. The independent variable is the one, again, in which you manipulate. So it is, again, for example of pH, if I provided environments that differed in levels of pH, that's what I've done. That's what I've manipulated. And I want to show a relationship between it and what I'm going to measure from it. And that would be, of course, our dependent variable. It depends upon the manipulation that you did in the if statement. So if I provide multiple environments with varying pH, then what you're going to measure comes next. And you have to phrase it like that, not that. So again, I wouldn't necessarily say, then there will be more isopods in the less acidic environment. So we'll say that as an example. I'd rather say, or I'd rather have you say, the number of isopods will increase on average in the less acidic environments. Or if your hypothesis was they prefer more acidic, then of course you would just word it like that. You would change your phrasing to say, again, something like this. If I provide multiple environments with varying degrees of acidity, then the number of isopods in the acidic side would increase. And so that's measurable. That's something that we can measure. And those are the things that I'll be looking for. If you state it with the if and then, it shows that prediction in the relationship between both the dependent and independent variables. If you look down to the next column, this is materials. Materials, that's pretty self-explanatory. Just write down what you've used. Your procedure is what I've been referring to as your methodology. Um, your procedure's got to accurately test a hypothesis, so you've got to be able to explain how you set up your choice chambers to test for your hypothesis. Conduct or analyze at least 3 trials. If you end up having restrictions on the number of trials you have for because of the limited time that we had in class, and I will not count off for this, but the more trials we can run, of course, the better results you're going to get. The next bullet point, of course, is procedure is in vertical list format. It's accurate, complete, easy to follow, and reproducible by another person. That includes diagrams to clarify procedures. This is where the iPad comes in handy, where you can take pictures or you can draw out different portions of your procedures. One of the things you need to include in your lab report, of course, is going to be any kind of safety concerns, which should be fairly short for this lab. Some of the things you may want to address is the use of sharp equipment to construct your choice chambers. Data collection. Data tables contain accurate, precise raw data and summary data. What we mean by raw data is the data that you collected out of the field just as it was. So as you're recording, it'll of course be your isopod counts. The summative or summary data is going to be averages or things like that, things that summarize your data. Make sure that you have you summarize what the data says in an organized, easy to read graphs. Make sure that your graphs are labeled. Make sure that the appropriate variables are on the correct axes. Make sure that you include a title and any kind of key that you may need. But the data needs to be summarized in a logical manner, and you can try and describe patterns that may be there. But the thing that you don't want to do is that you don't want to draw any conclusions. You don't want the why. You see the patterns here. Instead, you just want to maybe identify them. And then, of course, the conclusion is where you're actually going to say the why. Scientifically valid, logical conclusion, well supported by the data collected. You need to make sure that the data collected is you're in the conclusion that you're addressing how the data relates back to either accepting or rejecting that hypothesis. You also need to include sources of error, so be critical about how you construct your choice chambers. Be critical about how you could have introduced error into this. Try not to make things up, but look for valid sources of error. And then, of course, how can you reduce that error? How could somebody, if I picked up your experiment, how could I then run it without those sources of error? You also need to include specific questions for further study. So if maybe, again, going back to the pH, if the isopods showed a preference for a higher pH than normal neutral soil, then perhaps there's a sweet spot. Perhaps there's a particular pH that they would want, something that was more acidic but not too acidic. So you could phrase your questions in that realm. If you end up going through and constructing your lab report and you're not sure, you have questions or you need help with anything else, shoot me an email. Let me see what you've done and I can help you with that. So until next time, then, bye.